Hey guys, so today we're going to start taking a look at parallel and perpendicular lines. So first, let's just sketch them. So when we talk about parallel lines, we're talking about lines that when they're graphed, they never touch each other. So that's what physically parallel lines look like. And then when we talk about perpendicular lines, we talk about lines that intersect at a right angle. So that's, again, what actual perpendicular lines look like. And then sometimes we just have intersecting lines that don't intersect at quite a right angle. So those are neither parallel nor perpendicular. They just intersect. So I'm just going to write the word neither. All right, so let's talk about algebraically how we determine it. Of course, we can observe it if they're graphed, but let's talk about how we can do it algebraically without a calculator. So whenever we look at two lines, if they have the same slope, those lines are parallel. If they are perpendicular, those lines will have what are called opposite reciprocal slopes. And so just to give you a few examples, 1/2 and -2 are opposite reciprocals. The signs change and they flip the number. So let's say you had 4. The opposite reciprocal of that would be a negative, and just think 4 means 4/1, so you flip it to 1/4. Here are a couple of more. Let's say we started with -3/4. Well, the opposite sign is positive, and if you flip it, the reciprocal is 4/3. So that's what I mean when we talk about slopes that are opposite reciprocals. So I want you to pause the video and make sure you get that down. Parallel lines have the same slope, and perpendicular lines have slopes that are opposite reciprocals. That's what we're going to focus on in this lesson. So now let's compare things. Sometimes whenever you are given two equations, so you need to solve for y, or get them into slope-intercept form. So let's jot that down. So get your lines into slope-intercept form and then compare the slope to determine whether the lines are parallel, perpendicular, or if they're neither parallel or perpendicular. So let's look at the first example. Y equals 3/5 x minus 3, and 5y equals 3x minus 10. First of all, can we easily see the slope in both? Well, I can see the slope in the first one. It's 3/5. But I have to do a little bit of work on the second equation. I have to divide everything by 5 to get the slope. So y equals 3/5 x minus 2. Now I can see that the slope of the second line is 3/5. So let's discuss what that means. Well, if we look back at our notes, if lines have the same slope, they're parallel. So these two lines, if they were graphed, would make or create parallel lines. So let's look at a couple more examples. Let's compare these two equations. Y equals -1/3 x plus 2, and y equals 3x minus 8. First, can I easily identify the slope in each of these equations? Nicely enough, they're both in slope-intercept form, so I can just compare. And they are opposite signs, and 1/3 and 3 are reciprocals. So since they have opposite reciprocal slopes, these create perpendicular lines. Perpendicular lines. So that's the relationship between those two lines. And again, we get this by looking at the slope. Same slope means the two lines will be parallel. Opposite reciprocal slopes means they will be perpendicular. Take a look at these two equations. We have y equals negative 2x plus 3 and 2x plus 4y equals 10. So the first one is nice. It's already in slope-intercept form, so I notice my slope is negative 2. But the second one, I need to change that around a little bit. So I'm going to subtract 2x from both sides. So 4y equals negative 2x plus 10. And I still need to divide everything by 4. So y equals, well, negative 2/4 simplifies to negative 1/2. Remember, because they both are divisible by 2. So remember, that's how we reduce fractions. So negative 1/2 x and 10 over 4, those both also reduce by 2, although that's really not important to this lesson. But that is that equation in slope-intercept form. So now my slope is negative 1/2. First of all, are they opposite signs? Or are they the same? No, they're both negative, but one is a 2 and one slope is 1/2. So they're reciprocals, but not opposite reciprocals. So I'm going to say that these are neither. They may intersect if I graph them, but they're not parallel and they're not going to be perpendicular. Now let's take a look at how to actually go the other way and write these equations. We're going to use everything that we know about writing equations. So for the next example, we're going to write a line, and I'm going to simplify this, that is parallel to this equation, and it goes through this point, 4, 7. So one more time, parallel to the equation y equals 3x plus 6, and it goes through the point 4, 7. So first of all, parallel, what does that mean? If I look at my notes, that means I want to have an equation with the same slope. So I need to get the slope out of this equation. So my slope is 3. So now that I have my slope and a point, let's think back. Slope, point, so I need to start with the point-slope form. So y minus y1 equals m times x minus x1. So this is your x and your y. So this is going to be y minus 7 equals, what's our slope? 3 times x minus x1. Oh, we know what the x1 is. Sorry about that. The x1 is actually 4. So if I leave it in point slope form, that would be okay. But let's go ahead and get it into slope-intercept form, because it seems like that's what everything is in today. So I do my distributive property. 3 times x is 3x. 3 times negative 4 is negative 12. I'm going to add 7 to both sides. So y equals 3x minus 5. And I do notice those have the same slope, so we are good. Now let's write a perpendicular line. So we want to write an equation, and we're just going to stick with slope-intercept form, that's perpendicular to, 5x plus y equals 1, and we want it to go through the point 2, negative 1. So what does it mean for an equation to be perpendicular? Well, that means that it has to have an opposite reciprocal slope. Can I easily find the slope of this equation? No, I can't. So before I can identify the slope, I have to get it into slope-intercept form. So I subtracted 5x and got y equals negative 5x plus 1. Now I have my slope. Perpendicular, remember, perpendicular means I need an opposite reciprocal slope. So my slope, what is the opposite of negative? Positive. What's the reciprocal of 5? Well, 5 really means 5 over 1. So my opposite reciprocal to negative 5 is positive 1/5. Now I can use that and the point in point-slope form to write the equation of the line. So y minus, my y in the point is negative 1, which becomes y plus 1, two negatives make a positive, equals, my slope is 1/5 times x minus 2 is my x. And again, let's go ahead and solve this for y and get it into slope-intercept form. So y plus 1 equals 1/5 x minus 2/5. And I'm going to subtract 1 from both sides. So I end up with y equals 1/5 x. And remember, 1 as a fraction is 5 over 5. So negative 2/5 minus 5/5 is going to give us minus 7/5. So this equation, y equals 1/5 x minus 7/5, is perpendicular to this equation. And I know that because the slope is a negative or an opposite reciprocal. Take your time, use your notes to help you with your practice, and I'll talk to you guys